everybody. Welcome to our talk, From Coast to Coast, Implementing DBT in the Public Sector. I am Jenna Jordan. I'm a data engineer with the City of Boston, representing the East Coast.
Hey folks, I am Ian Rose. I'm the Senior Data Engineer in the Cal Data Division of the State of California's Office of Data and Innovation.
And I'm Laurie Merrell. I am an analytics engineer at Jarvus Innovations, and I actually live in Chicago, so third coast.
So I'm going to give a brief overview of our talk. We're going to start out by talking a little bit about the public sector versus private sector data work and what sorts of things make public sector data work a little different from private sector data work. Next, we're going to dig into a little bit of why this might be a good time for public sector data workers to take a serious look at DBT for some of their data transformation needs. This part of the talk, with apologies to people in the room with us today, is going to be targeted more towards public sector data workers who are DBT curious and are maybe not so familiar with it. The bulk of the presentation will be us digging into some specific case studies of projects that each of us has been working on. Our respective organizations are set up a little differently from each other, and this has consequences for how each of our organizations has implemented DBT. And then we'll wrap up with some synthesis and share out some resources that we and others have implemented.
So by the end of this talk, we'll hopefully want for everybody to be able to answer the question of, if you are a public sector data worker, then should you implement DBT? Is it right for your organization? And if so, what is the best implementation strategy? Because we're going to be demonstrating or talking a little bit about some different implementation strategies that we've done at Outwards. We've got 3 different case studies, so 3 different approaches. And I also just want to reiterate, the audience here is going to be very familiar with DBT. Hopefully what you'll get out of this talk is learning more about how the public sector is different, but also just so ripe for opportunity for improvement by implementing DBT. And then the folks joining at home or watching the recording afterwards will hopefully be able to learn more about DBT. So if you already know some of the stuff we present, which I guarantee you will, just ask for your patience. So, City of Boston analytics team, which is housed within the Department of Innovation and Technology, was founded in 2015. The team size has fluctuated, but currently we are at 15 members. The analytics team kind of serves as an internal consulting team for the different city departments. So we do data work for another team that may not have the capacity to ingest data and build out a data pipeline and a dashboard. As of about 4 years ago, our infrastructure is mainly housed through Civis platform, which provides our workflow orchestration and also manages our Postgres database. On the engineering team, we have 7 engineers total, 3 who are city employees, 4 who are contractors. And our job as data engineers is to manage the ETL pipelines and our data warehouse. And then the analysts use that data warehouse in order to build reports and dashboards. You can see our stack of tools here, primarily centering on Civis platform. Data engineers use Python to build out custom ETL scripts. We use YAML for our Civis workflows. We use SQL for most of our transformations. Some transformations are in Python. We're using the Great Expectations Python package for our data unit test. And now, as of starting about 6 months ago, we're using DBT Core. And most recently, we're able to say we have put it into production.
So, like I said a moment ago, I am with Cal Data. It's a division of the Office of Data and Innovation within the state of California. It's recently been promoted to a full state department as of this year. So our department is, we act as sort of internal consultants, researchers, and solutions architects for the state. We help go out to other state departments and try to improve data operations within them. One consequence of this is that we are not the long-term product owners for any of the data work we do, and so like capacity building and training are a huge part of our projects and of our sort of client engagements. Our infrastructure is built on Snowflake, DBT, some PyData stuff, Airflow, AWS, but the state is absolutely enormous, and so we have to be flexible. There's a certain amount of Azure, GCP, Oracle in the mix as well.
And I am going to be talking today about the CalITP, California Integrated Travel Project, but I am a consultant with Jarvus Innovations, so we are a private consultancy working with public sector clients, and the case study today is CalITP, which is a project managed by Caltrans, the California Department of Transportation, and that initiative is focused on improving public transit and public transit data quality in the state of California. And our data stack is mostly Airflow, GCP, DBT, and Metabase for BI.
All right, so I'm going to talk for a minute about public sector versus private sector data work and what makes government data work maybe a little different from what most people here have worked on. So right off the bat, I'd like to talk a little bit about process. The process in public sector data work can be significantly more difficult than private sector work. Procurement of things, including SaaS tools, can take months or years. Purchase orders can be legally and logistically complex. Budgets are smaller. They're limited and they're often sort of uncertain from year to year. So one sort of consequence of this is that there's frequently a lot of work done up front for big IT or tech projects that lead to a sort of a waterfall style project management, where you build this big monolithic enterprise code base and then it goes immediately into maintenance mode. In our keynote this morning, there was some discussion of waterfall style project management as part of the history of software engineering. It's kind of alive and well in the public sector. And that's just, it's part of the culture in a lot of places. There's also a lot of siloed data. It can be difficult to get departments, even within the same level of government, to share data with each other, let alone sort of different parts of the government. Engineering decisions are also often downstream of data governance policies, which means that like changes in tech stack often require updates to policy, and updates to policy can be as much or more work as actual engineering work. On the other hand, there's an extremely wide breadth of problems. A lot of the data domains that you hear about at conferences like this have to do with marketing funnels, have to do with financial data, have to do with like web analytics. All of those exist in the public sector. They're very useful domains. But there's also lots of other things that we have to deal with on a daily basis. We get to work on transportation, we get to work on housing data, there's natural resources and climate data. We have to be flexible. We have to be ready to dive into domain-specific problems, and it can be really fun and rewarding.
All right, so if you are wondering why DBT, for the folks who are joining remotely or watching the recording and are not super familiar with DBT, why should you invest time and energy into implementing this open source project? So first I want to say it's important to know that in the world of open source projects, DBT is a pretty safe bet. It's become industry standard. We learned at the keynote this morning that now over 30,000 companies are using DBT, so our chart is a bit out of date. It's from about 1.5 years ago. But the open source project, DBT Core, is mature, over 5 years old. It's well documented. It's actively maintained and developed, and it has a fantastic community of users and developers. And all of those are an absolute must for using a open source tool in a world where somebody else is going to have to pick up and continue using it. And you're probably not going to want to do migrations very frequently, so it should last for a while. And DBT at this point now is just the foundational and first step towards implementing the entire modern data stack tool set. I want to pull a quote from a blog post published about 3 years ago called "Why is DBT Important?" Which is, if you choose not to use DBT, then you'll probably waste time building a less fully featured, buggy implementation of it yourself, which is what we did before DBT became well-known and popular. So that really resonates with me. It's not right for every org. DBT is only really going to be useful for your city or state data team if you meet these 3 criteria. So if you meet it, then I strongly encourage you to consider it. If not, then it's probably not going to be so useful for you. So first, you want to have a data warehouse or plan to have a data warehouse or some kind of central database that you're using for analytics. Second, SQL should be your shared language for interacting with data. And it would be a bonus if there are some team members who are familiar with Git in the command line. Third, DBT is going to be most useful for you if you're regularly ingesting data into your database and you want that data to flow through a transformation pipeline. Not every data team fits what this looks like, but if that sounds like you, then I strongly encourage you to check DBT out. As you can see from the diagram, DBT is just for transforming within your database. So just want to make that clarification as well for those who may not be as familiar with what it is. But if you meet all these conditions, then what DBT is going to provide for you is this. You're going to be able to move all of your SQL code, your data transformations out of your team members' heads and down into a version-controlled shared code base. Documentation is made easy. It's integrated into the development process. And then you can very easily surface that documentation, visualize with data lineage charts on a website for your team or anybody else who should have access to it to be able to see it and explore. You can schedule and orchestrate these transformations, know how fresh your data is, and implement a whole suite of pre-made data tests or very easily write your own custom data tests. It's all just SQL and YAML. So if DBT is sounding pretty good right now, know that you can implement it at your org, whether you tend to have a top-down or bottom-up data governance culture. So if you have a bottom-up data governance culture, DBT Core is going to be a good option because you can start building today. It's open source. And you can slowly build up your business use case and demonstrate the value to leadership. That's what we did. And if you have a top-down culture with management that supports DBT, then DBT Cloud is going to make that whole development and transition process easier and faster and speed up the widespread adoption of DBT and facilitate any upskilling. So either way, you're covered.
All right, let's talk some case studies. So I'm going to kick us off with a case study about the state of California's recruitment and hiring data. California is an enormous state. We have a quarter of a million employees at any given time, and there are millions of job applications yearly. Along with those millions of job applications, there's also hundreds of millions of sort of hiring-related events that are tracked in big transactional databases. This is a large enough amount of data that the state's recruitment analytics teams were having some challenges working with it. They had questions about demographics. They would have strategic questions about the effectiveness of certain hiring campaigns or how long to keep job posting open. And the sort of state of the art for dealing with these questions would be to do something like email IT. IT would write some big ad hoc query. They would cross their fingers that it would complete and not take down the transactional database, and then email an Excel sheet. This is probably a familiar story to a lot of people in the room. It was the status quo for teams like these up until a few months ago. And it really hampered some of these important questions that they had, including some statutory reporting requirements that they had. These teams were extremely familiar with their own data and also very good with SQL, but they had limited experience with version control, with CI/CD, with scripting languages like Python. So that really made DBT sort of a good fit for this team. So our approach was to string together a number of SAS tools, including Fivetran, DBT, Snowflake, and Power BI, for an end-to-end, mostly SQL pipeline. So people didn't need to learn any other programming languages. They did have to learn how to use Git and GitHub and do some basic version control, and that wound up being some of the stuff that they had to spend the most time with was just getting comfortable with the pull request-driven workflow. But there weren't really any new programming languages to learn overall. Our timeline for this, we kicked this project off this summer. Within a few weeks, we had people trained to use basic DBT pipelines and use Git and GitHub. We had some initial models going within a few weeks. Within 2 months, some of the business analytics teams were connected to the initial data models using Power BI. And then we sort of had a prototype Power BI, suite of Power BI dashboards deployed internally within the state within basically 3 months and change of kicking off the project. And so for a team that was just being introduced to these new workflows, we felt that was a really compelling story.
So for CalITP, it's a little bit different than kind of starting basically greenfield development. For us, we inherited an existing data pipeline that used individual Airflow DAG tasks for SQL transformations, and which was becoming very, 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 very painful as the project scaled. And so we were kind of trying to migrate an existing pipeline to use DBT. So our team, the Jarvus consultant team, was comprised of 2 analytics engineers and 2 data engineers. And we were supporting kind of a varied user population. So we had some analysts who are kind of pretty dedicated data users and maybe sophisticated data users. We had maybe more casual customer success or operational type users who might be like pulling data more ad hoc for specific customer inquiries. And then we also have some data products that are like pretty public facing or serve transit agency kind of external users directly. So we, as our user base was growing, that's how, and our data needs were scaling up, we were running into challenges with just using Airflow. And also I think worth calling out, kind of related to what Ian said before, that we're also supporting kind of a combination of operational use cases that might be kind of familiar to folks across sectors in terms of like dashboards to look for maybe data quality issues or kind of supporting a customer support workflow. But we also have, our analysts are often doing kind of research work where they're trying to do maybe more detailed kind of research type analysis and produce more kind of large data products that are maybe facing towards a more specialized audience, which again, I think is that example of like these interesting and kind of varied use cases that can exist in the public sector. So on the right side of this slide is our stack as it is now. We still use Airflow for our data ingest orchestration. We use DBT Core, and then we use Metabase for BI. We also use Jupyter, a hosted Jupyter Hub instance for the analysts to do kind of data science work, and then we publish data directly to the California Open Data Portal. And the main kind of project for the case study is just that we were basically inserting DBT into the middle of this diagram, and the rest of it was mostly set before we were implementing DBT. So our implementation, because we were starting with this existing kind of set of SQL transformations and we were just trying to take them from Airflow into DBT, that part was actually really fast. It was only like maybe 6 weeks to 2 months to just migrate everything, because we already had SQL code written, we already had like the warehouse was already set up and everything. So that was fast. Again, it speaks to the speed that DBT can really deliver value quickly. We then proposed a very significant rewrite because of limitations in our existing data ingest process. And if you want, one of the people on our team presented at Coalesce last year. Michael Chow had a presentation about, I think it was the reluctant analytics engineer, talking about some of the challenges with Airflow and some of this migration. So plug for that, I guess. But we ended up doing kind of a very significant rewrite. Once we'd migrated to DBT, we then did a DBT rewrite where we refactored basically everything from the ground up because there had been some foundational assumptions made early on that were incorrect, and then before we inherited the project. And so that rewrite took a little longer. That took maybe 4 months. And then since then, we've kind of been iterating, developing new features, dealing with bugs. And I think it's also worth mentioning, another thing that maybe makes this project unique is that a lot of the data that we're ingesting is scraped from like just the web. So we're downloading public transit data just from all the transit agencies across the state. And so the data quality coming in is variable. And so that's one of the reasons that there's a lot of iteration and a lot of bugs, is because people are producing new data and it's not like an API with documentation. It's like 100 data producers who are producing stuff and updating it, and then we ingest it and we kind of have to deal with that in real time. And one specific thing that we did that I thought might be interesting to public sector folks in particular is that we automated our open data publishing. So the California Open Data Portal is based on CCAN, and this is just another example of the kind of thing that DBT can help facilitate, because previously publishing to the Open Data Portal, it was a manual process. I'm gonna kick it off. And now we were able to kind of leverage some of the native functionality of DBT. So the open data is defined as an exposure in DBT, and so we can see all of the data that flows into it, which helps us, identify up front, like if we're changing something, is that going to potentially affect what we publish to the Open Data Portal, which helps us, prevent bugs or causing issues. But then also the structured data that DBT produces, like the manifest, we actually leveraged to write a script that parses the manifest and then turns that into some of the metadata and data dictionary files that are required for CCAN. And then we also use that to automate our publishing weekly. So instead of having to do a manual process, kind of ad hoc on a random schedule when people had time, we can now publish weekly. When we need to update the data dictionary, we can just run a script and it will pull the data documentation from YAML files that are kind of already part of the DBT project, which again means that that stuff is all within version control. Like we can see historical updates to that. And so kind of a lot of the things that come for free with DBT also enhanced kind of our downstream workflows, which saved us some time. And so this is the open data on the portal, and it gets updated and it doesn't take very much work anymore.
So at Boston, we had the project of migrating a mature code base with a ton of pre-existing pipelines and data products. The data analytics team has been around for 8 years now. We've been on Civis for 4 years. We've got a lot of code to migrate over. And so we also knew that we had Civis to be our orchestration platform. For those who may be unfamiliar, Civis is an orchestration platform specifically tailored towards governments and nonprofits and the progressive data community. And so the fact that we had an existing orchestration platform, we had procurement constraints, and our engineering team was already familiar in using VS Code, Git, and the command line, made DBT Core a good option for us. And so just for anybody who may be unfamiliar, this is what a standard Civis workflow looked like for our team. In each task, we're importing in a data source, we're doing a transformation, we're doing a data unit test, we're sending it on somewhere else. Standard workflow. We are spinning up a Docker container to do one single SQL query. And it took 5 minutes to run due to some libraries that needed to be loaded. So there's huge room for improvement here by implementing DBT, because we're going from this project-oriented structure over to all of our transformations and data unit tests for the all projects run in one single task, which also necessitates a few other redesigns. One of the things we needed to redesign was our schemas. So on the left, you can see a subset of what our schemas look like. They're divided by access level, open, internal, restricted, which we wanted to keep, but they're also divided by department or team or data source or a catch-all. We had a COVID internal data for everything created during the COVID times. And so we knew that the structure wasn't going to work very well with DBT. So redesigned a new set of schemas, keeping the access level division of open, internal, and restricted, but instead of dividing by team or source, we're dividing by where that data is in the data processing pipeline. So we have schemas for staging, a dev schema, which is brand new. We did not have a development environment. Having a development environment is great. We made the controversial decision to have one single development environment rather than one per user. But that is what worked for our team. And so far, it's proven to be the right choice. So breaking the rules is fine. And then production. So there's no more confusion over staging tables versus production tables. Like, what table should analysts use? If it's in the production schema, it's a production table, safe to use. And then after the new schemas were developed, which was done in concert with the whole team, choosing out the names and approving the new schemas, we could start building the foundations of the DBT project, loading key sources into the new staging schemas. And a lovely thing happened with our team. We had some very strong synergy around the fact that we made the decision to transition from Tableau to Power BI, which meant we had a whole new set of dependencies. And this was great because we had two different teams doing two different transition projects, so division of labor that could be in sync. And the engineering team could build out the new dependencies that would be used for the Power BI dashboards. And we didn't have to worry so much about overwriting previous tables. Everything was in a separate set of schemas, new set of dependencies. That synergy really helped us, especially in terms of project planning, because we knew, okay, these dashboards need these tables. We need to build out these models first. And so after our DBT project had a few completed transformation flows, we could show off our doc site. Here's a general project timeline. We really started in March with the new schemas, and as of this month, we are in production. We have DBT running every day. We've got about 200 models at this point that are mostly transitioned over, some new ones. And our engineering team is onboarded, and it's just been a really great transition with a lot of surprise synergies. And so our engineering team has three major goals where DBT helped to solve some pain points. First of all, the biggest one, we now have a data catalog, which we've been talking about for years and years and never have had a data catalog. And now we've got one that's automatically generated, updated every day. And that documentation has been hugely helpful in jumpstarting some data governance strategy, and which is a new, renewed focus for our department. And our data warehouse is no longer really a black box, which is great because that helps with change enablement, change management, and allowing us to better cooperate with other teams in our department and other departments as well. The development process for new tables is faster and better. We've got some great macros out there, so dry code is great. And it's much easier now to develop new custom tests. And instead of our data unit test results being trapped in log files onto this platform, it's data in our database that we could build a dashboard on.
So just to wrap up with some of the kind of the lessons that we've learned across these case studies, a big one is to be flexible and meet people where we are or they are. We kind of mentioned that like you may be working with folks for whom things that people sometimes take for granted, things like Git and version control, may be new. And so you have to make sure that you meet people where they are, and remember that just because someone isn't familiar with the tools doesn't mean that they're not familiar with the data and that they don't have a lot of expertise to bring to the project. And you want to make sure that you're working with people and leveraging everything that they know. Culture shifts, take time, and you need to be patient if you want it to be a success. And again, kind of building consensus is really helpful. Contextually balance incremental adoption versus leveraging kind of synergy with other things. So if you can target a couple early, little quick wins that help build buy-in, like, there's some pain point that you can just go for and fix, or like some dashboard people have wanted for a long time and you can just make it, that's great. But then also kind of be aware that like some changes may be easier if there's like other migrations, like the Power BI migration that helped like make sure that you're kind of contextually evaluating what's the most effective thing that I can do and what might go better with other changes that are coming down the line. One of the culture shifts might be the idea that iteration is good. As mentioned in the beginning, folks may be much more comfortable and familiar with waterfall style practices, and so just getting people used to the idea that iteration is a good thing, and that just because a test fails one day, now it might be much easier to fix that failing test. And so kind of helping just shift people into this model of like, it's not a one and done installation. We now have a project that we're all going to maintain, and that allows us to grow and add new features and all these great things. But it is kind of a different mindset than that massive, big bang software installation. And so just helping people get familiar and comfortable with that. And then don't be afraid to break the rules if there's something that doesn't work for you. So evaluate, what you're doing, why you're doing it, and constantly evaluate. Best practices are great, but make sure that you're kind of adapting them to your context. And I think with that, yeah.
So I just want to say quickly, we view this talk as a start to the conversation. And I'm guessing some of you who are curious about how we've implemented DBT want to see the code for each of our organizations. To the degree that we have been able to, we have made that code public. So that's the entire code base, or just the skeleton of it in Boston's case. But that code is all up on GitHub, and we've also collected them together into one repo. And we also now have the Slack channel, industry public sector, on the DBT Slack. And so if you have any further questions for those remotely, want to connect, let's build that community.